Good morning, students. So today we'll discuss about this chapter, new chapters, second chapter of physical chemistry, that is the solution. Okay. So you have already read some topics like as normality, formality, molarity. There are many topics you have already read in class 11. Okay, and also you have already done the numericals from this chapter. So there are some topics. These are the topics, these are already included in this chapter, that means in solution. So first topic is concentration terms. Okay, second is vapor pressure, third is colligative properties. Under this topic there are subtopics are given below. First of all, relative lowering vapor pressure, elevation in boiling point, depression in freezing point, and fourth one is osmotic pressure. Okay, now we will discuss the next topic, Van 't Hoff factor, then solubility of gases. That means here has a law. This law is called Henry's law. Is this clear? These all are the topics we will read in this chapter. Okay, now we start from solution. Definition of solution. You all know what is the definition of solution. Solution is a homogeneous mixture of two and more substances which lose their individual identities and cannot be separated by simple method. Simple method like as such as filtration. Okay, filtration means this is very simple method. Okay, only filtration has done. Okay, and see here has solution means binary solution. Binary solution means two different components are also present in the solution. Two different components. That means not only water. Okay, here water, and you can use any liquid, that means any syrup. Okay, or any solid like as sugar, salt. Okay, then solution has formed. Now in case of solution has two parts. You all know the first part is solute and second part is solvent. Solute means smaller amount of this substance is present in solution. Solute always present as a smaller amount of the substance, but in case of solvent, larger amount of this substance is present in solution. So solution means smaller amount and solvent means larger amount. Okay, now if we have taken some 20% ethanol solution, then 20% ethanol solution means what? Here as a solute 20 ml ethanol is added and as a solvent 80 ml water is added. Is this clear? Okay, now overall solution will be 100 ml. Now in case of 80% ethanol solution, in case of 80% ethanol solution, which one is as a solvent and which one is as a taking part as a solute? So 80% ethanol, here 80% ethanol acts as a solvent and 20% water acts as a solute. Is this clear? Okay, now the second topic is, this is the all about the introduction has already given. Now second one is concentration terms. Okay, concentration terms are just related about the two topics. First one is volume related and second one is mass related. See, volume related topics, that means what? Volume related means what? We all know volume means what? Temperature dependent. Volumes always related about the temperature dependent, and mass related means what? Temperature independent. So temperature dependent means percentage of volume, that means V by V percentage. Weight percentage by volume, that means W by V in short. Okay, molarity and normality. These all concentration terms are included the volume related. That means they all are temperature dependent. Okay, these four topics are all temperature dependent. But temperature independent terms are W by W, mole fraction, molality, and ppm. ppm means what? Parts per million. Okay, or you can say as billion. ppm means actually parts per million. Now this one is the mass related. Now see, we have already discussed all of these term in class 11. Okay, so you just read this topic. And also solve the numerical problems. Okay, from your book. Now we just move to the next topic, that means vapor pressure. The short form of the vapor pressure is Vp. Okay, now this is very interesting topic. See, vapor pressure means what? It is also related from the evaporation. You all know evaporation means what? Evaporation is a process where from it is a process when a liquid state just change to the vapor state. Okay, this process is called evaporation. So evaporation has taken place. First of all, we will discuss about the bulk molecules and the surface molecules. See, this is a open container. We have taken some solution. Okay, see, first of all, solution means there are many molecules of solute and solvent is present. Okay, now first of all, there are two types of molecules are present: bulk molecules and surface molecules. Is this clear? In case of open container, in not only open container, you can also use this term in the closed container also. First of all, bulk molecules always present inside the solution. Is this clear? Bulk molecules of solvent or solute always present inside the solution, and surface molecules are always present near the surface of the solution. Okay, so is this clear? The position of the bulk molecules and the position of the surface molecules. Okay, now you should better understand that which molecule means bulk molecules or surface molecules. Which molecules evaporates first? It is very simple. Surface molecules evaporates first because they are present just near about the surface. Is this clear? So first of all, surface molecules evaporates first, then the bulk molecules. So see here, bulk molecules are present inside this solution, but surface molecules are present just near the surface of the solution. See, there are some properties. Surface molecules evaporate first. Lesser force of attraction they have face. That means in case of surface molecules, lesser force of attraction are created. Okay, if lesser force of attraction, why lesser force of attraction is created in case of surface molecules? Because see, this is the surface molecules. Only force of attraction creates just below. Okay, just below of this molecule. See, not the upper side, because upper side is vacant now. Okay, no solution is present. That means only force of attraction creating at their below of their position. But in case of bulk molecules, the force of attraction creates in all of these directions. See, all of this direction. Okay, that means this in case of bulk molecules, more number of force of attraction are created, but in case of surface molecules, lesser number of force of attraction are created. That means what? In case of surface molecules, they evaporate first. Why? Because lesser force of first reason is lesser force of attraction, and second reason is more kinetic energy than the other molecules. Is this clear? More kinetic energy than the other molecules. That means surface energy. Surface molecules. That means more kinetic energy than the other molecules. Kinetic energy means what? Surface energy. Is this clear? For these two reasons, they evaporates first. They means what? Surface molecules evaporates first. In case of open container, weight of liquid will decrease. We never talk about the vapor pressure in case of the open container, because vapors escape from the solution. Is this clear? Okay, so we can never talk about the open container. Now we'll discuss about the closed container. Now what happening here? So first of all, see, in case of closed container, see, this is a closed container. Okay, here also solutions are present. These are the surface molecules, and see, these inside these molecules, these are called the which molecules? Tell me which molecules? These are the bulk molecules. Now first of all, in case of closed container, vapors can never escape from this closed container. Okay, so we all know from liquid to vapor, this process is called evaporation, and from vapor to liquid, this process is called condensation. Okay, now in this process, equilibrium also achieved in this process. Now see, all of these molecules, that means this solution A, these are the molecules of the surface molecules. These surface molecules, when they are starting evaporation, then what happens, they have a, this gas has a pressure, that means this gas means only A. Okay, after evaporation, A turns, this solution turns into gas. Okay, gas means what, vapor. So it has own pressure. This pressure is called vapor pressure of pure liquid, that means PA naught. Okay, PA naught means what, vapor pressure of pure liquid A. Okay, we have taken this liquid, only liquid A. Is it clear? In equilibrium, the pressure of vapors above liquid surface is called vapor pressure. Is this clear? In equilibrium, that means when equilibrium achieved, that time the pressure of vapor create above the liquid surface, this is called vapor pressure. Okay, now which factors are depending about the vapor pressure? Okay, factors on which vapor pressure depends. Now first factor is, it doesn't depends upon the shape and size of container. Okay, doesn't depends the shape and size of container. It depends upon only the nature of the substance. It depends upon only the nature of the substance. How? See, first of all, we have taken two examples. Okay, now first example is water and second example is ethanol. See, we have taken the two molecules of water. We have taken the two molecules of water and two molecules of ethanol. See, in case of water, we have already read in class 11 about the hydrogen bonding. See, in case of water, there are 4 hydrogen bonds are formed. Okay, that means hydrogen bond means we all know this is also strong bond, but here in case of two molecules of water, 4 hydrogen bonds are formed. But in case of ethanol, 2 ethanol makes only 1 hydrogen bond. Okay, 2 molecules of ethanol only make that 1 hydrogen bond. That means after comparison between the water and the 2 molecules of water and the ethanol, which bond will be strong? Obviously water molecules, 2 molecules of water. Is this clear? That means strong bond means what? Vapor pressure in case of water, vapor pressure will always less than that of ethanol. That means vapor pressure of ethanol is greater than the vapor pressure of water. Okay, if vapor pressure is greater than the vapor pressure of water, vapor pressure of ethanol is greater than the vapor pressure of the water, then what happened? Vapor pressure means what? P naught of ethanol greater than P naught of water. That means can we say that if force of attraction increases, then the vapor pressure of solution is decreased. Is this clear? Okay, now the vapor pressure of any solution is inversely proportional to the force of attraction. FO means force of attraction between molecules. Now in case of, now here is a question, arrange the order of the vapor pressure of ethanol, glycol and glycerol. Okay, ethanol, glycol and glycerol. See, in case of ethanol, less number of hydrogen bond is present. That means only 1 hydrogen bond is present. But this is the, see, this is the structure of, this is the structure of glycol. How many hydrogen bond will be present here? 1, 2, 3 and 4. 4 types of hydrogen bonds are present. That means in case of glycerol, there are, sorry, not glycerol, glycol. This is the structure of glycol. In case of glycol, there are 4 hydrogen bonds are possible. Okay, but in case of glycerol, how many hydrogen bonds are possible? 1, 2, 3, 4, 5. 5 number of hydrogen bonds are possible. That means if there are more number of hydrogen bonds means what? More number of hydrogen bond means strong bond. They can never evaporate fast. Okay, evaporation will be very slow. That means more number of hydrogen bond means what? Strong bond, and their vapor pressure will be less. That's why what is the order of the vapor pressure? Vapor pressure of glycerol will be less than that of vapor pressure of glycol, then less than that of vapor pressure of ethanol. That means ethanol, the vapor pressure of ethanol is always greater than the others. That means glycol and then glycerol. Okay, this is the second point. Okay, now third point is, it also depends upon the nature of the substance. That means vapor pressure also depends upon the nature of the substance. How? See, substance has 2 types, volatile and non-volatile. Okay, volatile means what? volatile means it has a normal tendency or common tendency to evaporate. Okay, volatile means it has a common tendency to evaporate. That means here vapor pressure does not exist. Sorry, here vapor pressure is always 0. No, actually vapor pressure of no, sorry. So first of all, vapor pressure, that means the pure vapor pressure of any solution can never be 0, not is equal to 0. Okay, that means what are the examples? Examples are water, then CH3OH, methanol, ethanol, benzene, toluene. Okay, that means vapor pressure can never be 0. P naught can never be 0. Okay, but in case of non-volatile liquid, in case of non-volatile, not liquid, non-volatile substance, that means solid, they are all solid. That means vapor pressure always 0. Vapor pressure will be always 0. Okay, that means vapor pressure means, that means this is the P naught means always, not means what? Pure vapor pressure. Okay, which have a common tendency to evaporate. Is this clear? Okay, which have a common tendency, which have no tendency to evaporate. That means, see, first of all, volatile substance means what? It has a common tendency to evaporate, but in case of non-volatile substance, it has no tendency to evaporate. So that's why the vapor pressure of pure solids, that means pure vapor pressure, will always 0. And examples are urea, glucose, sucrose. Okay, urea, glucose, sucrose. This all about the factors. Now, fourth factor is, see, this is the last factor. See, fourth factor is, see, vapor on temperature. Okay, about the temperature, vapor pressure always depends upon the temperature. You all know, if temperature is increased, that means what? Evaporation is also increased. Evaporation, why evaporation increased? Because vapors, if temperature increased, that means vapors are also increased. Number of vapors are increased. Number of vapors means vapors particles are also increased. Then evaporation increased, that means vapor pressure is also increased. Is this clear? Actually, from this term, this is not directly proportional. You cannot say this is the not directly proportional. We all know vapor, if temperature increase, that means vapor pressure is also increased, but actually it is not directly proportional. Is this clear? Why? Because see, this is the curve. Directly proportional means what? This curve is like that, but no, this cannot curve this is not like that. Curve is always this type. Is this clear? This, if vapor pressure increase, then if temperature increase, then see, vapor pressure is also increased. Is this clear? Now, okay, now next day we will discuss about the vapor pressure of the solution containing two volatile liquids. Thank you.